Hello, this is Josiah Winslow recording for his Data Structures and Programming course at MATC for instructor Mark Cribb. Now, you'll be happy to know that I did settle on a development environment and I am doing Visual Studio Code and I'm writing my assignments in Python. Now, Mr. Cribb, you said that you'd be interested in seeing my solutions for this assignment in Python, and I hope you're as happy as I am. So, I'll probably get to uploading this to GitHub every so often. Once I figure out how to get Git Bash installed and working on my computer. I'm using a new computer for this. I have everything in a folder I call DSAP22, that's Data Structures and Programming 2022. And this is my Assignment 3 file, which uses the single linked list class in a module that I call utils. That's stored in this folder right here, alongside all of the assignments. It's a very simple module. It basically just imports everything from the linked list and node source files that I've provided and puts them in the global namespace. So I'm just going to go over them really quickly, and I'm not going to go over too much of them in detail because a lot of them are just the implementations that were given in your videos, Mr. Cribb, but my own version of them. So with that out of the way, and I also added type hints just in case I need them later, or anybody else who's using this needs them later. And I also added doc strings, which were actually pretty simple to add. I use the NumPy doc string format, and I'm following that as closely as I can. Pandas also uses a variant of this for its doc strings. But anyways, so this node class is very simple. It has a next, which can either be none or an S node, which S node stands for singly linked list node. And this optional right here means it's this thing or none in the type checking module. And it has a value, and it can be any or none, and it'll be value. And then here are some string and repr magic methods. Pretty standard. Now let's go over the linked list class. I import the S node from my node file. And then here's the constructor for this class. It takes an iterable and it takes a mu. Now, iterable is just going to be anything that you can iterate through, one object at a time. And mu will be an integer, and if they're specified, then they'll be used to populate the list. So, first we start off by setting the head to none. And then if the iterable was specified, first we try iterating through it in reverse and continually prepending to the list, because if you can do that, that is faster because prepending is faster than appending. But if we get a type error from doing this reversed right here, if we get a type error, that means that somehow the iterable is not reversible. This happens with some iterables that are given by the itertools class or itertools module, and this also happens with sets that I've noticed. So if we can't reverse it, then we just go through it forwards and then append each item to the end of the list. And if mu is provided, then we insert a cycle starting at index mu, and it's where the tail points to the object at that index, or the node at that index. So first I put all of the magic methods, the ones with the double underscores. Sometimes they're called dunder methods. So this len magic method returns the number of nodes in the list, which coincidentally happens to be the sum of the two return values of my find cycle function. Now, my find cycle function returns lam, which is the length of the cycle, and mu, which is the starting index of the cycle. And I made special cases in the cases where there is no cycle, such that whenever they're added together, they give you the number of nodes in the list. Iter right here is another magic method, which it should be a generator, which allows each of the items in the list to be returned in sequence. And this will work with the for in syntax in Python. So this just iterates through each item of the list in a standard way. And here I have get item and set item. Now, get item and set item, the implementations that I gave are very, very similar, except the last line is different. Here I return p dot value, which basically the function is I just walk to the desired value, and then I either return it or I set it to something. And then this will work with the bracket syntax. For example, if you try to get item 0 in the list, it'll give you the head, or the value at the head anyways. And if I try to get the item at the 1th index, it'll be the next item after the head, and then the 2th index will be the next item after that, and so on and so forth. The stir and repr magic methods are different string representations of an object. Stir is meant to be human representable or human readable, and it is outputted by default whenever you try to print something. And also if you try to convert it to string using the stir method. However, if you try to convert it to a string using the repr method, then it'll run repr instead. You'll see what these look like in a sec, but basically stir is meant to be easy for a human to understand when they try to look at it, and repr is meant to be easy for a programmer to understand. Or for Python itself. Theoretically, you should be able to take the output from repr and paste it into a Python REPL or interpreter or program or whatever, and then get the original object back. So that's exactly what I do. And I get the class name by doing self.class.name. This, by the way, also uses f strings, which ever since they were added, I'm really, really fond of them. I love them. They remind me of the what was it? I'm forgetting what the character is, but it's the one that's not the tilde on the tilde key. Backtick. There you go. It was backtick. In JavaScript, they have backticks that basically do the same kind of thing and let you use code in string formatting like this. And it's a feature I really, really love. I think it's new to Python 3.10. This clear method is very, very simple. It sets the head to none. That's all there is to it. Now, append, prepend, and insert are very basically just straightforward implementations of the methods that you provided, Mr. Crib, in your videos. Except I've like done a lot of testing to make sure that they behave nicely with lists that have cycles in them, because sometimes it had not been behaving so kindly. It hadn't been preserving the cycle, and if you tried to, this was a problem with the removing elements functions as well, where if you would remove, for example, the first element of a cycle, then it would still be there like at the end, and the cycle would be sort of like half broken. It was a weird thing. I did a lot of testing for this, but rest assured, here's my append function, my prepend, and my index. And I have this here, by the way, because I feel like I should be able to handle a negative index, because after all, this is Python, and you can use, for example, negative indices to get items starting at the end of the list and, you know, going backwards. But I wasn't sure the right way to do that, so I decided to just give up. So there is the condition where if you're trying to insert something at the beginning of the list, I instead have it use prepend because the other way wasn't working. And this is me walking to the right element and then exchanging the links to insert it. And now here is my pop front, pop back, and pop at index functions, which are basically the same thing, except also in my pop back function where I remove the final element, I have to make sure if there is a cycle, I have to make sure that that cycle is preserved. The last element should still point to whatever element it was pointing to before. And that is what requires me to walk through the entire list right here. And also, each of these returns the value which was removed, which, by the way, I really should add that as a type hint. Each of these, I forgot to up until now. The type hints don't affect anything really, and in fact, a lot of the code that I've written before in Python didn't have them at all, but I thought for both my benefit and the benefit of anybody else who might want to use this, that this would be useful to them. So yeah. And here, by the way, is where I account for the special case of removing the first node in the cycle. What I would want is for the last item to still point to that index in the list, but now that the new item has been put in its place, it's a different item. I can probably explain in like a Discord message or an email or something. I don't know what I'm talking about. So here's my index method where I try to search for the first index of a given value in the list. And this is very self-explanatory. Because I can iterate through the list, I do that using enumerate to get both the index and the item, which I really love about Python, that you can do this. And if the value of that node is equal to whatever value you specified, return the correct index, and if you went through the entire list without finding it, raise a value error. This reverse function is a very straightforward implementation of the reverse algorithm in your videos, Mr. Crib, except I just quickly check for a cycle, and if it exists, then I say, you can't do it. This isn't implemented. Whoops, battery saver is on. That means nothing's wrong with plugs. I'll figure it out later. Yeah, I'll figure it out later. Anyways, so here we have, we're sorting by values, sorting by swapping the values, and it's a bubble sort. Now, what I decided to do for this is the sort function on Python lists takes both a key and a reverse as optional arguments. Key is some function that is applied to each of the elements before sorting, and reverse is a Boolean where if it's true, it sorts in descending order instead of ascending order. So I decided to implement that myself. I make a list of every key that I basically sort in parallel with the linked list. And then here's the function that decides whether or not I should swap, two indices that are next to each other. And it depends on whether or not reverse is true. To know if the bigger thing should go to the end of the list or to the beginning. This is not exactly bubble sort. It's an optimized version of bubble sort. You should be able to find it on the Wikipedia article for bubble sort. And it's a pretty straightforward implementation of it. And here you can see I use tuple unpacking to swap the keys and the values that I'm trying to swap. How many? Okay. And here we have sort items. It's basically the same thing, except I swap the links, which I don't feel like you explained it that well in your video. This is kind of what I got stuck on for a bit, so I prepared a sort of a quasi-slideshow for this. And I'm just going to go through it really, really quickly. So, this is an example of a linked list. Now, what would we have to do to swap nodes P and Q? And we're also keeping track of O right here because we're going to need it later. Well, first, we start by having P point to this node, which is after Q. And we're just going to call this R. I didn't give it a name, but we're going to call it R. And then Q points to P. So then the order now is P, or the order is Q, then P, then R. Simple enough so far. And the reason we were keeping track of node O before is because it also has to be redirected to point to Q. So then before we had to OPQR, now it's OQPR. And by the way, if O doesn't exist, if there's no node before P, if P is the head of the list, let's say, in that case, then we can't make it point to something else because it doesn't exist. So instead, Q is just the new head of the list. So now we've got everything in the right order, except the whole loopy arrows thing is a little bit messy. So we're just going to fix the visualization. That's better. But there is still one problem, even though we have everything in the right order right now, and that is the fact that node P isn't referring to the same index in the list as it was before. And if we try getting the next item and the next item and the next item after this, we will have skipped this node Q right here. So what we have to do is swap the variables P and Q to make sure that P is still pointing to the index in our linked list that it was before, and we can iterate through it as normal. There. And I hope that helped if anybody was confused. I'll probably timestamp this and post a comment about it or something like that to help any students who want to get to this section quicker. But anyways, yeah, that is... Okay. I gotta figure out how to put this in right now. There we go. We still good? All right. We're almost in the home stretch. So, this method inserts a cycle, and it does it by assigning the node that we want to have be the starting index to this variable called target. And then we still walk P to the end because we're going to make P, which is now the last node in the list, point to target. Very simple. Find cycle. I'm not going to go over this because this is just Floyd's tortoise and hare algorithm, which everybody else is also implementing, and I feel like this is self-explanatory enough. But again, I'll probably be uploading my code somewhere so you can review it in more detail. And by the way, I return it as a tuple of lam and mu because you can do that, and it's very helpful that way. I've been using a whole bunch of lines up here, for example, that use tuple unpacking to get both of those values and put them in separate variables. And yeah, I thought that was the best way to do that. And then finally, we have a function to remove a cycle, where we walk to the end of the list and then set that next to none. All right, so that's that explained, and the last thing to do is to test this out. Now, I'm not going to walk through this code, I'm just going to walk through running it. So here we have to initialize the linked list. Let's just say we want to have it be the digits of pi. 3, 1, 4, 1, 5, 9, 2. That'll do. Starting index of cycle. I'm going to test all of these functions out without cycles, but rest assured I did test them with cycles and they all worked. So, these are the things to do. Let's first display the list. And here we go. Here's the string representation and the repr representation. And as you can see, this looks just like a call to the constructor for single linked list with all the items. And let's do count nodes. We should get a value of 7. Length of list is 7. Perfect. All right. Now let's try to search for a value in the list. Let's try to search for the number 4. And we should get back an index of 2. Value 4 found at index 2. And we can try to insert something at the beginning, like let's say we're inserting 314 at the beginning. We're inserting 628 at the end. And then at position 2, we are going to insert 161. How about that? All right, now what does our list look like? All right, so this was inserted at the beginning, then this was inserted at the end, then this was inserted at position 2. All right, now let's delete from position 2. Now it's deleted that thing, and then deleting the first node and last node. And as you can see, it's also giving us whatever value was there that we just deleted. So we just deleted the 314, 628 that we added before. And so now these look just like they did before. So I'm just going to go ahead and copy this just to save it for later. We're going to reverse the list. And then now we've got the digits of pi, but in reverse order. And we can reverse it again, get the original list. All right, now we're going to test out our sorting methods. We're first going to sort by exchanging data. And then we're going to sort by exchanging links. The result we should get is 1, 1, 2, 3, 4, 5, 9. 1, 1, 2, 3, 4, 5, 9. Perfect. So let's just quit out and then reinitialize that. And we're going to... Yep, right here. And we're going to sort again by exchanging the links. And there we go. 1, 1, 2, 3, 4, 5, 9. Perfect. Now there are 3 more functions left to test. That is insert cycle, and where do I want it to start? I'll have it start at index 1. All right. So now when we do detect cycle, it says a 6-length cycle was found starting at position 1, and the length of the list is 7. And let's check out the string representation. So as you can see right here, all of the, well, in this case it's only 1. All of the 1 element that's not in the cycle just starts out right here. And then whatever's in the cycle, it's in these brackets. And pointing, 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 all the way to these ellipses, which I thought was the best way to tell the person, hey, there's a cycle here. And for the repr, what we have is just all of the items in order, but also the starting index that I provided before. 1 is the second argument to the constructor. So now let's remove that cycle. And then now if we detect the cycle, it should say, yep, no cycle found. Length of list is 7 still. And then output it again. Yippee, no cycle. Now, I spent a lot of time trying to get this to work with lists that do have cycles, specifically the inserting and deleting, and also getting and setting items at positions. Oh, that's right. I didn't test that yet. We should do that. So we should try getting the last item, which is going to be the item in index 6. And that's 9. Which it is. Let's try setting it, finally, to something crazy, like -27. Index 6 set to -27. Perfect. And just for kicks, let's sort that again. Love it. Alright, so that is it for the demonstration. I've definitely done a lot more testing with it than that, and rest assured it does work with all of those test cases that I've tried. I'm going to be probably uploading this to GitHub very, very soon. If not, then, please remind me by next time. And I'm probably going to use that linked list class to help me implement my stack and queue functions that are going to be a part of our next few assignments, as far as I understand. And with that, yeah, this is done. Take care.